What we do in a regression is we do hypothesis tests for whether this quantity right here is different from 0. Why would we do that? Well, because if this quantity right here is equal to 0, then our prediction of your GPA will be beta 0, will be the same number regardless of whether you get advising. If beta 1 is equal to 0, then there's no difference in the mean GPA between those who got advising and those who didn't. So that's the null hypothesis that we use, that beta 1 is equal to 0, and then we test and see whether we have evidence to reject that null hypothesis. Let's relate that to a couple of concepts. This relates to the idea of comparing an equal means model to a separate means model. The separate means model says that the mean in the no advising group can be different from the mean in the advising group. The equal means model says, no, they really should be the same, so we should average all the points together to figure out our prediction of anybody's GPA because advising doesn't matter. The hypothesis test for whether beta 1 is equal to 0 corresponds to comparing the equal means model to the separate means model. And it does make use of the residuals. How far is each point from the mean in its own group, and how far is each point from the overall mean? The other concept I want to relate this to is a t-test. Turns out that if you run a t-test and assume equal variances, comparing an advising group to a no advising group, comparing just two groups, that is exactly the same. The p-value you get is exactly the same as the p-value you get when you do the test to see whether this beta 1 is equal to 0. Because it's the same thing. We have two groups. Each group has a mean. Those means are either the same or not. The null hypothesis of a t-test is that the means in two groups are the same. The null hypothesis of this test is that the means in the two groups are not different. It's exactly the same thing. A t-test with equal variance is exactly the same as the hypothesis test that goes along with the coefficient for an indicator in a regression where that indicator is the only predictor.